All right, let's take a look at homework number 14, starting first with multi-step literal equations. In this topic, you will need to isolate the given variable or specified variable. So in this case, it asks us to solve the equation for a, and that means that a needs to be by itself, and the other letters need to be on the other side of the equal sign. So I'm going to take a screenshot here of this so we can take a closer look. So for us, we have two letter A's. And when you have two specified variables, you need to get that down to one specified variable. So what I want to do is prevent D and 7 from both multiplying by A, right? So what I'm going to do is I'm going to factor or undistribute this A. I'm going to bring this A back outside the quantity and factor it out of each of these terms. So if I don't multiply D by A, if I don't multiply 7 by A, I have factored it out like this. And now I can simply isolate A by dividing by this entire quantity, D plus 7 on both sides. You can use parentheses, but you don't have to. So the value we're going to type is B divided by the quantity D plus 7. That will be your solution here. So capital B divided by the quantity D plus 7. Whoops, I typed a 9. All right, let's try the next one. Okay, so they want us to solve the following equation for A. Let me take a quick screenshot here. Move to my other screen. And place it here. So we want to isolate A. Again, we have an A in two different terms. So I'm going to use the same math move that I used last time, which is I'm going to pull that A out of this quantity. So A is going to be factored out. 2m cubed minus n will remain. And I want to get A by itself, so I can simply remove this entire quantity 2m cubed minus n. Not too bad, but it is reviewing this new technique for you, which is factoring, and that is likely how the question will be asked. So capital B divided by the quantity 2m cubed minus n. There we go. 2m cubed minus n. Yes. I like it. All right, let's take a screenshot of this one here. Solve for letter G. Solve for letter G. So here we go, new page. All right, looks like G is part of a denominator. So what I'm going to do is I'm going to remove these fractions on both sides here. I want to get rid of dividing by G, and I want to get rid of dividing by T. So they both are inverses by multiplication, so I'm going to multiply both letters at the same time. I want to multiply both of these quantities by GT. So these G's will cancel, but the T and the H still need to be multiplied. And these T's will cancel, but the G and the 4 capital R still need to be multiplied. All right, we want to get G by itself. So now I have to divide both sides by 4R. So I'm going to divide both sides by 4R, allowing me to get a G by itself. TH divided by 4R. TH divided by 4R. Lowercase t, lowercase h divided by 4 capital R. All right, you getting the hang of it? All right, so last one we'll do together. Solve for B. And when we solve for B, we need to remove any item that is being added or subtracted first. So I'm going to subtract t from both sides. M minus t equals 1/2 b. And now I can clear my coefficient. So I'm going to multiply by 2 over 1. Multiply the entire side by 2 over 1. That eliminates my fraction 1/2. So I'm actually not going to distribute. I'm going to leave it as a quantity. But you could write 2m minus 2t. You could write that. but I'm just going to leave it as 2 parentheses m minus t. Sorry, there we go. All right, next topic, transforming formulas, very similar, but specifically you're not just given random letter combinations, you are given a specific formula. This one happens to be called the Pythagorean theorem, which is helpful for finding missing sides of a right triangle. And we learned about that in the 8th grade. And we are trying to solve the formula for the positive values of c. So we want to get c by itself. C is almost by itself, so what's new that you learned this year? The inverse of exponents, and that is roots. So the opposite of a square is a square root, so we're going to square root both entire sides. So your answer here is a giant square root sign on the left, and these square roots cancel over here on the right. So the square root of a squared plus b squared. Here we go, square root sign is down here. I'm going to press Shift 6 to get my power, but you could also use this keyboard here. Right? So you type B and then you press this square button. There you go. You could also open the Delta Math keyboard. Well, let's take a look at another formula, the perimeter formula for a rectangle. We want to solve the formula for L. So I'll take a quick screenshot here. So when we're solving for L, that means we are going to eliminate this entire 2w term at the very beginning. So p minus 2w is equal to 2l. And now I can divide either the whole side by 2, or I could split it up and divide them separately by 2. The choice is yours. This first one would result in this answer. And this second one would result in this answer, either 1/2 or p over 2 minus w. I'm going to choose the first answer, so I'm just going to write a giant fraction. So p, and then I'm going to go back up here, p minus 2w all over 2. All right, one more time, solve for v. So the first move I'm going to make here is I'm going to multiply both sides by v, right, giving me this equation, and now I can divide both sides by d, and that isolates my letter v. So sometimes you have to use the actual letter you're trying to isolate. You have to actually use it in the math moves. So m divided by d, m divided by d. Awesome, I think you're getting the hang of it. I'm going to go to the next topic here, plot points and graph quadratic functions. So there's going to be lots of points here, but you can only graph the ones that will fit on this 10 by 10 grid. So it looks like we can start at -3, -8. Then we're going to go to -2, -2. Then we're going to go -1, 0. Then 0, -2, and then 1, -8. And I can tell here it has a power of 2, so I know it is quadratic, so it would be a U shape. So I'm done plotting my 5 points. And now I'm going to try and connect them here using my finger on the trackpad, making a nice connection from point to point, and extending it until I see those arrows. Let's see if it gives it to me. I'm not really happy with this right here. I'm actually not really happy with that. But let's just see what it says. Oh, it gave it to me. Fantastic. See, I was a little bit off. It should be a nice soft curve up at the top. All right, again, you pick 5 points from your table. That would fit. So -5, 9. -4, 4. -3, 1. -2, 0. -1, 1. That looks like 0, 4. See how I have some symmetry here? Right, see how I have some symmetry here? I'm actually going to plot a couple extra, and now I'm going to make a nice soft curve. Well, I don't like that. I'll make a nice soft curve down here at the vertex. Then I'm going to lift up my finger and do bit by bit. Not going too crazy with my arrows far away. Okay, let's see how we did. Excellent. You're going to do the same with absolute value functions. This is to get you used to learning the shapes. So I'm going to plot here -5, 5, -4, 6, -3, 7, -2, 8, -1, 9. Now I know that an absolute value function is not a straight line, so I'm going to go back and graph some of these other points because I should get a V shape here. -6, 6, -7, 7. There it is. There's that V shape I was looking for. So the more points I draw, the straighter my line will be when I, oops, oh no, I accidentally deleted all my points. -5, 5, -4, 6. So I remember it was symmetric, so I can kind of just plot them back real quick. Now I'm going to draw a nice straight line here, a nice straight line there, and voila. Alright, same is true for graphing square root functions. Now you'll notice this one has undefined. That means there should be no graph in that area whatsoever. So we're going to start at 0, 0, and 1, -2. 0, 0, and 1, -2. These are not integer values, so I'm going to skip them. 4, -4, 4, -4, and 9, -6. So there we go. And remember, you cannot have an arrow going past this. So this is your endpoint. So do not draw anything to the left of that because it is undefined. It's undefined. All right, last one is exponentials. So the same thing with this one here. We're going to plot, oh, it's asking you the asymptote. That's a new question for you. So when does the graph approach a number but never pass it, right? So I get smaller, 1/2, 1/4, right? 1/8, 1/16. I'm getting smaller and smaller and smaller, but I never ever will actually get to 0. So the asymptote is 0. And I know that because it never ever actually gets to 0. It hovers over it, right? It's hovering very close, but it never actually passes that number 0. Plot at least 4 points. All right, 4, 1, 5, 2, 6, 4, 7, 8. Now, a lot of you had some trouble with this last time. What? One of my plots is wrong. 4, 1, 5, 2. 4, 1, 5, 2, 6, 4, 7. Oops, this one, 7, 8. Okay. And now I'm going to draw my curve upwards, but I don't want to pass that asymptote, right? I want to get that. Oh boy. So hard, but don't pass that dotted line. Don't pass that dotted line. Okay, let's see what happens. Yay! Right, as long as you don't pass that asymptote, you're going to get full credit. Let's try one more time. Let's see, where does it start getting small, small, small? It's -5, -6, -6, 6, 6, 6, 6, but it never goes to -7. So that's the asymptote. So there's a line. It's never going to pass that -7. So -5, -6, -4, -5, -3, -3, -2, 1, and -1, 9. So it looks like it's getting very high here. So I'm going to shoot this up with an arrow, but then I'm going to go and hug this dotted line, but not go past it. All right. That's it. Good luck.